Hi everyone, and welcome back to another episode of Bluverse. Mapping of petroleum systems is a critical stage of hydrocarbon exploration, and today geoscientists are leveraging deep learning in their established workflows to better characterize them at a higher level of detail. And so today I'm joined by our geophysical advisor as well as our QA engineer, Scotty Salamoff. So Scotty, welcome on the show, and tell us a little bit about yourself as well as your experiences.
I spent the last 16 years of my career in exploration and production, finding oil, drilling prospects, and working in play types of all different kinds across the world. Today, what I'd like to talk to you about is utilizing deep learning to map petroleum systems. And petroleum system mapping is something that's traditionally a very complicated process. And what we'll hopefully demonstrate today is how deep learning can help take this complicated process and streamline that, making it more effective and powerful.
See, and today we'll be looking at the case study from the Scarborough area. So Scotty, can you tell us why Scarborough is sort of the perfect exercise to use interactive deep learning on?
4 of the 5 main petroleum system elements that we deal with are very well imaged. And the data itself is of quality that lends itself to deep learning processes. The 5 basic elements of a petroleum system are source, reservoir, seal or closure, migration, and containment.
Gotcha.
So 4 of those, the source, migration, reservoir, and seal, are very, very well imaged in Scarborough. The 5th one is the lateral containment, and that we can demonstrate is provided by a combination of stratigraphic and structural mechanisms.
I see. And so here we have the source rock interval, or as we say, the kitchen, right? This is where everything forms. We can see that there's quite a bit of offset that's present throughout the area. So what does that mean, Scotty? What is the significance?
Well, in our case, when we're looking at a gas field like Scarborough, what that means is the source rock interval is being faulted, and the generated gas in that source rock interval has a high enough pressure to exceed the sealing pressure of the faults, or the containment pressure of the faults. So what that means for us is that where we can see the source interval offset by faulting, which connects itself to the reservoir, we can safely assume that these faults play a role in fluid migration.
I see. And so these hydrocarbons eventually migrate into the reservoir, right?
That's correct. The reservoir in the Scarborough area is a 3-tiered fan sequence deposited in a basin floor setting. So with interactive AI, what that allows us to do is very quickly come up with P10, 50, 90 ranges for area. The 3D character of the predictions also lets us start bracketing P10, 50, 90 ranges for gross rock volume, or GRV.
I see. And we can also see how these basement faults are further offsetting the reservoir and illustrating the story of migration as well as compartmentalization. But obviously, as they migrate, something needs to keep everything in place, correct?
That's correct, Julian, absolutely. And this brings us to the regional top seal in the area, which is the Mouterong Shales. We can see that the top seal has been breached in certain areas by faulting, and some of these deeper basement faults that go through the top seal, propagate up through the shale interval, and link up with some dewatering structures above them.
I see.
So all of this strongly suggests an important component that faults play in fluid migration.
I see. And we sort of touched on that a little bit, right? This fluid migration, fluid flow. So that's what the faults are serving, both the basement as well as the shallow faults?
That's correct. That's correct. The basement faults and the shallower dewatering structures are separated by a thick sequence of shale. And some of these basement faults end up propagating up through that shale and linking up, like I said before, with the shallower polygonal faulting or dewatering structures. We can see by the presence of some shallow gas in the area that the assumption we made involving faults and fluid migration is a valid assumption.
I see. And so eventually, right, as you go from the kitchen, source rock interval, all the way through the reservoir, through the seal, that's where then the shallow gas begins to form. And we see that manifesting as several puck marks on the seafloor.
Absolutely. The Scarborough area has about a 100 square kilometer leakage zone that manifests itself as pock marks on the seafloor. So we've got very, very good evidence of leak off in one part of the reservoir.
I see. And really, in the matter of under a day, essentially, we're able to characterize a complete petroleum system, right? And so what does that mean for someone like you that spent a lot of time on sort of the exploration production side of the industry?
Well, Julian, it absolutely changed the equation, and it makes creating more accurate, efficient, and effective models something it's a reality. It's also effectively a force multiplier. It allows a single geoscientist, such as myself, to do the work of an entire team. So what used to take several months can now be done in a day by a single person.
That's incredible. And really also, it starts to reveal that higher level of detail, right? Very quickly when we're looking at the source rock interval, the reservoir for paleoflow directions and things like that. It's incredible the level of detail that you can extract so quickly and tie that back to the business units.
That's right. In addition to making our jobs more effective and efficient, interactive deep learning forces us to be better geoscientists, because we have to think about what we're doing very hard while we're doing it, and we have to make sure that what we're creating makes sense in a geologic and geophysical context.
Absolutely. Well, thank you so much, Scotty, for coming on the show. We really appreciate you sharing your insights and also teaching us about petroleum systems. So thank you again, and be sure to like, comment, and subscribe for more satisfying bites coming your way.